everyone. Today you will be learning about sum and difference formulas, using them to evaluate the exact values of trig functions. And then your homework will be a Math Excel labeled the same thing. But before we start that, we're going to go ahead and practice in establishing the identity problem. So this is what you did yesterday. And I just want to remind you that when you are doing an identity problem, you can change either the left or the right side. It doesn't matter which one you choose, but whichever one you choose, you have to stick with it. You can't change both sides at the same time. This equation on both sides of it, both sides seem a little bit complicated, but I am more inclined to change the right side because I feel like I can change the tangents to sines and cosines, but it's a little bit harder to change what's on the left into something else. So I'm going to go ahead and manipulate the right side, and I'm going to do that by starting off and changing tangent into sine over cosine. And I'm going to also change tangent squared into sine squared over cosine squared. And then I need to change that 1. It needs to have a common denominator, and so I'm going to give that a common denominator of cosine squared, which means my numerator needs to be cosine squared. So I have changed every part of this tangent over 1 minus tangent squared into sines and cosines. Once we get to here, I'm going to get a common denominator, or I'm going to combine like terms with the one common denominator in the denominator. So this now becomes sine over cosine over cosine squared minus sine squared over cosine squared. And this is looking a lot like, or getting closer at least to looking a lot like what we have up here. So I feel like we're pretty close. So I think my next step then will be to multiply the numerator and the denominator by the reciprocal of the denominator. So I'm going to multiply by cosine squared over cosine squared minus sine squared in both places. And I apologize, I am using my finger and not a stylus because my good styluses are at school. All right, so there is what I'm multiplying by. I am going to obviously cancel the whole entire denominator, and then one of these cosines cancels with this one. So you can see that what you are left with is just sine times 1 cosine over that denominator there. So this becomes exactly what we were trying to show, which is sine times cosine over cosine squared sine squared. Minus sine squared. Okay, so from there, we're going to move on to learning about our new lesson. This was a way I was going to show you the formulas, but it's going to take too long for me to do in a video. So what I think I'll do is I'm going to make a separate video for just this part. And if you want to watch it separately, you can do so, but I don't want to spend too much time right now with it. Okay, so I'm going to put it on a different video for you. So here are the formulas that you should be filling in onto your handout. So we have 6 different formulas that you need to be aware of, but really you need to be aware of the first 4 for sure, and you do have to memorize them. So you have the sine addition or sum formula, sine, cosine plus cosine sine, and the sine subtraction formula, sine cosine minus cosine sine. Then you have the cosine addition and subtraction, and notice the signs, S-I-G-N, change. Okay, so they're kind of the opposite. And then there are these formulas for the tangent sum and subtraction formulas as well. But you could also just do sine of a plus b divided by cosine of a plus b, and that would be tangent of a plus b. So for instance, if you've already done the sum of a plus b for sine and then for cosine, you could easily find tangent without knowing the formula. So if it's too many formulas for you to memorize, feel free to just memorize the first 2 and use those for tangent addition and subtraction. Okay, talked a lot there in hopes of giving you some time to write that down. If you need a little bit more time, either pause the video or come back to it, okay? All right, so we're going to see how these are going to come into play. So a variety of different practice problems. So this is the first one we're going to do, and it's theta plus pi, and that means it's a sine addition formula. And so the sine addition formula is sine of the first angle cosine of the second angle plus cosine of the first angle sine of the second. Okay? And now you fill in everything you know. Well, you've already been told that sine of theta is equal to 1/7, and you hopefully remember that cosine of pi is equal to -1. So cosine of pi is -1. Okay, this is what I'm going to have to figure out is cosine of A, or maybe I don't, because sine of pi is actually equal to 0. So what this is doesn't even matter because we're multiplying by 0. So the whole thing actually becomes -1/7. Okay, second problem. Let me make sure I didn't need to scroll down. Okay, there we are. So now these, you have to figure out what the angles are that you're going to add together on your own. So we're trying to find two angles that add or subtract to give you the angles that are here. So when you do, excuse me, sine of 7 pi over 12, you want to think of what angles would add together to give you 7 pi over 12, but you want them to be angles that are on the unit circle. So I'm going to think of all of my unit circle angles and get them in terms of 12 in the denominator. So for instance, I have 1/6, or pi over 6, I guess, which is 2 pi over 12. I have pi over 3, which is the same as 4 pi over 12. I have pi over 4, which is the same as 3 pi over 12. So if you at least start with these three main angles, then it'll help you to figure out, like, will what I have here give me, can I get this from these two? And actually I can see it right here. 4 pi over 12 and 3 pi over 12 add to 7 pi over 12. So sine of 7 pi over 12 would be sine of pi over 3 plus pi over 4. So then you use the sine addition formula. Sine of pi over 3 cosine of pi over 4 plus cosine of pi over 3 sine of pi over 4. And now might be a good time for you to get your unit circles out, because you're going to need to remember all of these values as we continue through. But if it's been a while, you might want to take it out and use it as we're practicing here. So sine of pi over 3 is √3 over 2. Cosine of pi over 4 is √2 over 2. Cosine of pi over 3 is 1/2, and sine of pi over 4 is √2 over 2. So this whole thing simplifies to square root of 6 plus square root of 2 all over 4. Okay, now you're going to do the same thing for cosines, like cosine problem that you're going to get a negative angle for. So we're looking to get negative pi over 12. And I can actually use these same two angles again, but just do cosine with subtraction. So I'm going to do cosine of, let's go back up so you can see what I'm talking about here. So I'm going to do 3 minus 4 gives me a -1. So pi over 4 minus pi over 3. So I'm going to use my cosine subtraction formula. So it's cosine of pi over 4 cosine of pi over 3 plus sine of pi over 4 sine of pi over 3. Okay, now I am not recopying these formulas down because you just were supposed to have copied them down, but here it is. Excuse me. Okay, so this is the formula I am using. And again, now I just need to know what those trig values are. So this is √2 over 2. Cosine of pi over 3 is 1/2 plus √2 over 2 times √3 over 2. You actually, for this problem, get the same answer. Square root of 2 plus square root of 6 over 4. Okay. Last one now is tangent of 11 pi over 12. So it looks like I can't use the angles that I have here. I'm going to have to go one bigger. So, or maybe too bigger. Let's just keep going. So let's say if I use pi over 2, so pi over 2 is actually 6 pi over 12. So that's still not going to get me enough. So maybe I need to use an angle in the second quadrant. So I know I'm filling this all in crazy here. So if I use 2 pi over 3, 2 pi over 3 multiplied by 4 gives me 8 pi over 12. 8 pi over 12 plus 3 pi over 12 gives me 11 pi over 12. Okay, so I'm going to use 2 pi over 3 and pi over 4. So I'm going to do tangent of 2 pi over 3 plus pi over 4. And now is when you get to choose how you want to use the formula. Like, do you want to do sine and cosine separately? Since I haven't done that yet, it's going to be easier if I just use this formula. So tangent plus tangent over 1 minus tangent times tangent. Okay, so tangent plus tangent over 1 minus tangent times tangent. Okay, so again, we need to know our unit circle here. The pi over 4 ones are nice. Those are 1, so that's a 1. And then tangent of 2 pi over 3 will be large side over short side, so that should be root 3 over 2 over a half, but negative. Negative root 3 over 2 over a half just simplifies to negative root 3. So I get there. And then my denominator becomes 1 minus, this is a negative root 3 again, so it becomes plus like that. And you can just leave it like this. Again, we don't have to simplify or rationalize our denominators. Okay, hopefully that's making a little bit of sense. We're going to keep going. You could always rewatch the video or ask questions in class. All right, these are usually a little bit easier. This is actually working backwards from the formulas. So you're looking for what formula does this look like, and then write it backwards, and hopefully it's an angle on the unit circle. So this is sine cosine minus cosine sine. So sine cosine minus cosine sine is sine of A minus B. So this is sine of 42 minus 12 is what that actually is, which is sine of 30, and sine of 30 is a half. Okay, this is tangent minus tangent. This is the tangent subtraction formula. So this would be tangent of 104 minus 14. 104 minus 14, I believe, is 90. So tangent of 90 is y over x, which would be does not exist. So DNE or undefined. All right, finally over here, I have cosine, cosine minus sine, sine. This is actually the cosine addition formula. So this is cosine of pi over 12 plus 3 pi over 12, which is cosine of 4 pi over 12, which is cosine of pi over 3, and cosine of pi over 3 is a half. Okay, next. These are the types that you're going to probably see the most, where you're going to have to use like this information and make a triangle out of this information to then come up with this additional situation that we have here, okay? We're going to try really hard to give you triangles that are families. So like this is a 3, 4, 5 family, and this is 7, 24, 25. So we are going to try and make sure we give you triangles that you'll know from geometry. We're going to draw the triangle in the correct quadrant. So this is in quadrant 2 because it's from pi over 2 to pi. So in quadrant 2, sine is positive. That's a 4. Hypotenuse is 5. That means our adjacent side is negative 3. This is theta, okay? So now I'm going to use this picture and what I know about pi over 4 to solve this addition problem. So I'm going to use my formula, So the cosine addition formula is cosine theta cosine pi over 4 minus sine theta minus sine pi over 4. Cosine of theta, here's theta, cosine of theta is negative 3/5. Cosine of pi over 4 is root 2 over 2. Sine of theta was given to you, it's 4/5. And sine of pi over 4 is also root 2 over 2. So this whole thing simplifies to, let's see, negative 3 root 2 minus 4 root 2 over 10, which is negative 7 root 2 over 10. And kind of think about what that means. You're taking this angle right here, pi over, or this theta angle, and adding pi over 4 onto it. So you're moving it 45 degrees. So we're going to be moving it into the third quadrant, which is where cosine is negative. So you have a negative cosine value there. Okay, let's do this next problem. What is this? That's here. Okay, so now I have an angle of theta that is in the third quadrant between pi and 3 pi over 2. So here's my triangle, here's my theta. Since it's tangent, it's opposite over adjacent. This is a 7, 24, 25 right triangle. But since we're in the third quadrant, both y and x are negative, but that's why tangent is positive. Okay, so here's our picture. And we've used the tangent part. Now we're going to use the sine subtraction formula, which is sine theta cosine pi over 6 minus cosine theta sine of pi over 6. So now you're going to look at the picture. Sine of theta will be negative 7 over 25. Cosine of pi over 6 is square root of 3 over 2. Cosine of this picture is negative 24 over 25. And sine of pi over 6 is a half. And if you don't remember these unit circle values, you're going to have to go back and practice because these are not going to go away. Okay, the numerator doesn't combine, so it just gets written as two different parts. So negative 7 root 3 plus 24 all over 50. All right, so that's all I have for you. Move on to the next part of the lesson.